Problem number 10 on your midterm review. SATs are normally distributed with a mean of 430 and a standard deviation of 120. And the first question is asking us if students randomly selected, find the probability that he or she obtained a score less than 360. So what we have here given to us are the mean and standard deviation. So we have mu is equal to 430 and sigma is equal to 120 for our verbal SAT scores. And so what we're going to do is we're going to use this information to find the probability that somebody, randomly selected student, has a score less than 360. So here's our bell curve. It's good to note the mean of your bell curve, which is right in the middle. And we don't have to worry about the standard deviation, although if you have tick marks that show how many standard deviations away from the mean you are, you can mark that as a measure of 20 from the mean, or 120 is our standard deviation. Our 360 is a little bit less than this. I don't know exactly where. We can actually compute it and be a little bit more precise, but let's just say 360 is over here, and we want to know what the probability is that we get somebody who has a score of 360 or less. So there's several ways to do this. The easiest way is to use our calculator. First, let's set up our problem. Our probability that X, a randomly chosen person, is less than, score is less than 360. And what we're going to do is we're going to use the normal CDF function, because we're talking about normal distribution. So normal CDF, and if you remember the normal CDF arguments, it's low, high, mean, and standard deviation. So it takes 4 arguments. Now the low goes off technically to minus infinity. So there are several ways to do that. One way is to type in 1e. Oh, I'm sorry, it's a negative because it's less. So negative 1e to the 99. I'll show you in the calculator how to type that in. The high is going to be up to 360. The mean is 430. And the standard deviation is 120. Okay, so let's see the keystrokes in the calculator for this. Let's go to our calculator. The normal CDF is under distribution, so second function in vars. There's a PDF function here that we'll never use in our class. One more down is CDF. Press enter. Now negative, we'll start off making sure we have a negative sign. This is our negative sign. And then 1, and then the E is not this E for the Euler's constant 2.71. That's not what we want. We want this E that represents the power, or 10 to the power. Oops. That would be a second function, and the comma. That gives us that E, and then 99. So what we have here is essentially 1 with 99 zeros that's negative. That's way less than 0. And that's what we're looking for. Okay, now we put comma, and then just our regular numbers, 360. And the mean 430, and then a standard deviation 120. Okay, close parentheses and get our normal CDF value, which is 0.2798. Okay, it would really be good for me to see this normal CDF business to let me know what you're using in your calculator. The next question, similar. One student randomly selected, find the probability that they obtain a score greater than 440. So this is 430. Again, that's the mean. 440 is a little bit bigger than that. So let's put a marker here, 440, and then shade that in. It's also good for both you and me. It's good for me to see the bell curve, and it's good for you to draw the bell curve, because if you draw the bell curve you can clearly see your low and your high for your normal CDFs. So our probability that our score is greater than 440 is going to be a normal CDF. And again, we're looking at the low and the high mean standard deviation. So the low this time is 440. The high is now, it goes on forever, so this is a positive infinity. So we'll label as 1 e to the 99. Again, that's 1 with 99 zeros. And then 430 and 120. All right, back to our calculators. Remember our little trick to get the last function called, second function, and enter. Okay, so let's backtrack. And we'll start here with the low of 440, comma, and then 1, that e again. So second function and this double e, and then 99. And then let's check the rest of this input here. It looks like there's one extra zero I want to get rid of, so I'll delete that. Some calculator tricks here. Just to double check everything else, 430 and 120 as our mean and standard deviation. If we hit enter, it's 4667 or 4668. And here's our answer for the second. The third part, 100 students are randomly selected. Find the probability that their mean score is greater than 440. Now this is important. The 100 students are randomly selected. So this is in section 6.5, I believe, in your textbook, where they talk about the central limit theorem. If you have more than one person being selected, a group of people being randomly selected, then we have, instead of just using the regular mu, we use mu sub x bar, which happens to be the same as mu. And instead of a sigma, we use sigma sub x bar, which is, now this is different. This is sigma divided by the square root of n. So this is the big change that you'll have in this problem. So similar to this one, your graph of 430 as the mean and 440 as your lower limit is the same, except you should, this is not a big deal, but I think it's important that you label the mean of your sample to be your variable instead of just a regular x. 440, our x bar is bigger than 440, and then normal CDF. So this will be just like this last one. We got 440 e to 99, and then this should have been 430. Oops. Somebody probably caught that already, but here it goes, 430. Now this is the big difference. Instead of your standard deviation being the way it was, your standard deviation needs to be your old standard deviation divided by the square root of whatever n is. In this case, it's 100. Okay, and you could type it in just like that. I mean, square root of 100 is 10, 120 divided by 10 is 12. So that's easy enough to compute, but with more difficult numbers, I would just leave it like that and punch it in your calculator the same way. So being that this is exactly the same as the previous command in our calculator, so I'll just hit entry, and everything will be the same for us except this last part. It'll be 120 divided by the square root of 100. Then right arrow and then close the parentheses and all that. Hit enter, and then you have 2023. So that's your probability. Note that it's different. The probabilities are different between your part C and part B answers. It's less of a chance if you have 100 students that you're talking about. So let's see if we can answer the last problem. Suppose a research at Acme College prep program, and you're a researcher there, or you research that company, and you find that 100 of their students achieve a sample mean of 440. Does this seem reasonable to conclude that this is an effective program to enroll in? Well, the thing is that having 100 students and having a mean score of 100 students being bigger than 440, there's really a 20% chance of doing that. So let's see if we can write down our answer in part C here to make sense. There is a 20.23% chance that a group of 100 students get a sample mean score of 440 or higher. Now 20% is really not that small. If it was small, then it would seem like it would be reasonable to be able to support their claim, but 20% doesn't seem that small. I think small means we're looking at the 5% range, as in the empirical rule. So does it seem reasonable to conclude that this is an effective program to enroll in? You could say not really, because 20% does not seem out of the ordinary. Okay, so this is the important part in answering this question, a reasonable explanation in terms of your interpretation of that 20%. Okay, so that's the last problem number 10 in our practice midterm. Good luck on your test, and I hope this helps.